Okay, today's video is on variables on both sides of the equation. So our learning goal for today is that by the end of the lesson you'll be able to solve algebraic equations that contain variables on both sides. So thinking back to one of our previous videos when we're talking about equivalent equations. So equations are equivalent if we have the same term added, subtracted, multiplied or divided to both sides. So for instance 10 plus 5 is equivalent to 13 plus 2. And then if we just divide both sides by 2, they're still going to be equivalent equations because we're doing the same thing to both sides. So our answers are still going to be the same thing. Okay, so if we have a pronumeral on both sides of the equation, so for in our example here, we've got x on both sides. We've got 5 plus 2x on the left-hand side, and on the right-hand side, we've got 4x take 1. So we've got that variable x on both sides. So if the pronumerals are on both sides of the equation, what we're going to do is going to add or subtract the terms so that the pronumerals only appear on one side. So what does that mean? Well, let's do this example. So the way I would get rid of the pronumerals from one side is I would subtract them. So they're both positive, so to get rid of them we have to do subtract. And the one I would subtract is the 2x. So I'm going to subtract 2x from both sides. So 5 plus 2x take 2x is just going to equal 5. And 4x take 1 take 2x. Well, we can add and subtract like terms. So 4x take 2x is going to leave us with 2x take 1. And from there we can continue to solve for x. So we can continue to use our onion method. So we're going to add 1 to both sides. So 6 equals 2x, and then we can find out what x equals. So we're going to divide by 2 on both sides. So 6 divided by 2 is 3. 2x divided by 2 is just x. And like usual, we are going to check by substituting x equals 3 back into our original equation. So 5 plus 2 times 3 equals 4 times 3 take 1. So 5 plus 2 times 3 is 6 equals 4 times 3 is 12 take 1. 5 plus 6 is 11. 12 take 1 is 11. So yes, we were correct. Excellent. So we've got some examples here, and you can see we've got variables on both sides. So we've got our first one, we've got 9 plus 4t equals 7t plus 15. So to make the variables on only one side, I'm going to subtract 4t. Now, this isn't the only way to do this. If you wanted, you could actually subtract the 7t from both sides. That would only give you the variable on one side, but then you're working with negative numbers, and usually that leaves room for error. Lots of students always make errors when they're dealing. Lots of students don't always make errors. I should say lots of students make errors when dealing with negative numbers, and are usually more prone to making errors when you deal with negative numbers. So you could just as easily, and you'd be just as correct, subtract the 7t, but I always prefer to subtract the smaller number just to make it easier, so we're always dealing with positives. So 9 plus 4t take 4t is just 9. 7t take 4t will give us 3t plus 15. So then we're going to do our next step, which is take 15 from both sides. So 9 take 15 is going to give us a negative 6 equals 3t, and then we're going to divide by 3 on both sides so we can find out what t equals. So negative 6 divided by 3, so a negative divided by a positive is going to give us a negative answer, and that's going to be negative 2 equals t. So you can check t equals negative 2 by substituting it back into your original equation. 9 plus 4 times negative 2 equals 7 times, I'm probably writing on my face right about now, so 9 plus, that's a 9, not a 4, so 9 plus 4 times negative 2 is negative 8. 7 times negative 2 is negative 14 plus 15. So 9 plus negative 8 is the same as doing 9 take 8. So 9 take 8 equals negative 14 plus 15. 9 take 8 is 1. Negative 14 plus 15 is also 1, so we know we're correct there. Clear the screen. So we've got 6 take 7g equals 2 take 5g. So we are going to remove the variables. Now this time they're both negative, so we've got negative 7g and negative 5g, so the opposite would be adding. So again, it's up to you which side you want to do. You can deal with the negative 7g or the negative 5g. As I said, I always prefer to deal with the smaller number, so in this case the one that's furthest away from 0. So I'm going to do plus 7g to both sides. Again, you could do it the opposite way, you're still going to get the same answer. So 6 take 7g plus 7g is just 6. 2 take 5g plus 7g, so negative 5 plus 7 is going to give me positive 2, so it's going to be 2 plus 2g. Now to get rid of the 2, I'm going to subtract. Again, I know it's subtraction because there's no negative sign in front of the 2, which means it must be a positive 2. So 4 equals 2g. To get rid of that 2, I'm going to divide both sides by 2. 4 divided by 2 is 2. 2g divided by 2 is g. So g is equal to 2. So you can substitute that back in to make sure that that's correct. So 6 take 7 times 2 equals 2 take 5 times 2. 6 take 14 equals 2 take 10. 6 take 14 is going to give us a negative number, negative 6. Negative 8. That's not correct. This is negative 8 as well. Sorry. 6 take 14 is negative 8. 2 take 10 is negative 8 as well. So yes, we were correct. G does equal 2. For our last one, we've got 3 plus, where did my pen go? 3. Let's start again. We've got 3 plus m equals 6 plus 3m. Now, we're going to subtract the small one, so which is just the m by itself, so subtract m from both sides. So 3 equals 6 plus 3m take m is 2m. Moving on to our next one. So to get rid of that 6, we're going to have to take 6 because it's a positive 6. So that's going to give us negative 3 equals 2m. So we're going to divide both sides by 2. So negative 3 over 2 equals m. So we're just going to leave that answer there in fraction form. So that's fine. If you can't divide it, you can just leave it in fraction, or if you've got your calculator handy, you can turn it into a decimal and write it as a decimal. It's up to you, either way is correct. So if you do have any problems at all, make sure you do come and talk to me about it.